you want me to speak? Hi. Yes, a little bit lower. I speak very loud. Thank you so much. Okay, good morning, everyone. Oh, this is too loud. Can you a little bit? I speak very loud, and then when I also hear myself from the speakers. Okay, hi, good morning. My name is Niky Riga, and I'm with the GENI project office. So welcome to the GEC. I'm just going to do an introductory talk to GENI, and also do a demo at the end. So usually when we give this talk, we usually go around the room and let everyone introduce. Lately, we've been increased so much in number that takes a lot of time. But I still want to know, who you are, why you're here, so we'll just do it with questions. So for example, who is here because they want to run experiments in GENI? So who is here because they're developing GENI, they're writing tools, they're in the developers category? Guys, hi, so I can see you. Who is here because they are supporting GENI in operations, they have like a rack in their campus, they do we have anyone from international collaborations? Okay, did I forget any category? Anyone that didn't feel he belonged to the categories I said? No? Which one? The whole thing? Okay, let's go again. Who wants to run experiments in GENI? Good. Who is here because they're developing tools? Guys, up. Great. And who is here because they have racks they're supporting? And who is here from our international collaborators? Paul, you're not. Okay, welcome everyone. So I know that you all have different backgrounds and you're here for different reasons. So I'll try, my talk will be a little bit generic. Please feel free to interrupt me at any time to ask me questions as I'm going through the slides, because the topics are going to be changing, and by the end you might not remember the questions you had in the beginning of the talk. So let's get started. So first of all, let me tell you a little bit about what I'm going to talk about. So I'm going to start a little bit by motivating GENI, and then I'm going to present to all of you like the GENI concept, like how it was envisioned for GENI to being used, and Testbed. I'm going to touch briefly on what we're doing next, where are we now, and how are we moving forward. And then at the end, because this is all a little bit of high level, and it might not actually give you the tangible feeling of what exactly is GENI, I'm going to go through some concepts and actually do a demo in GENI. So how would you go about running an experiment in GENI so that you can actually see how how someone would go about using GENI. So how did GENI thinking, and how did we start thinking about building GENI? So global networks are there. Everyone is using them. We really rely on them. But on the other hand, is a network that is very complex. It's very scalable, and it's, anyone can plug in new devices to the internet, but that makes it very, very complex, very hard to study and understand, very hard to run, like repeatable experiments, or like hard to actually study the behavior with any confidence in a, in a science way. And it's also very, very, very hard to innovate, because all the access you have as an experimenter is usually at the edges. I mean, depending on where you have access, there are people, you might have access in one network in the core, but you won't have everywhere in all the devices in the internet. And just by changing things at the edges, you cannot necessarily innovate and write new routing protocols, write something new for the internet. So these are the problems we are facing in the current internet. So that's why they start thinking that maybe we do need an infrastructure in order to be able to do network experimentation. Somewhere that any experimenter can get resources in a large-scale test bed, and which is actually, like a wide area test bed, so it kind of resembles the properties of the internet or of a wide area network, where you can have access to all the levels within the network. So you have access at the edges, but you also have access at the core. And this is exactly what GENI is envisioned to provide compute resources that can be connected in experimenter-defined topology. So different experimenters will have different requirements about how they would like their topology to be set up, and be able to connect them in layer 2 topologies, so that you are able to innovate and you're not tied to IP like you are when you're running experiments in the current internet. So, questions? No. So we want, first of all, the first thing we want to do is that to be able to support multiple people at the same time, right? It will be a shame to build like such a build test bed that only one person can use it at one time. So the idea is that you have this basic infrastructure that then you take slices of this network and you give it to different people in order to be able to run their experiments, and these slices should be isolated. So one experimenter's traffic should not interfere with the other one. So the idea is that you can have multiple slices come up on the same basic infrastructure, and this will be isolated. So for example, the red experiment traffic shouldn't interfere with the green experiment traffic in this case, even if they share the same physical resources. So even if they're running on the same VM server, if they're going through the same switches, their slices should still be isolated. This is the first big design decision that we made in GENI, and the other is that GENI should be deeply programmable. So you should be able to, first of all, define any custom topology you want, and then run any protocol, or switch your flows, route your traffic any way you want. So I don't know if you heard about OpenFlow. So one of the things that GENI does, it has OpenFlow switches in key places, so that experimenters can actually get control over their own traffic and decide how they want to route their traffic and do switching decisions in the core of the network. Now, what type of resources we have in GENI? There are two major types of resources. One is the compute resources. And compute resources, you can imagine bare metal machines, you can imagine VMs, you can imagine wireless nodes, Android handsets, which is one of the recent ones, and anything that, where you can go and run your code. So and I'll talk later about the GENI racks, which is basically, a rack that has a lot of compute power, so that people can get either VMs or bare metal machines. We have the GENI wireless compute nodes, which you might hear in other session referred to as the yellow nodes, clearly because they're painted yellow. And we are also federated with existing test beds. So for example, if you're familiar with Planet Lab, with EmuLab, you also can get compute resources from there, right? And the next big category of resources that we have in GENI are networking resources. So for example, in the GENI rack that I was talking before, yes, there are all these VM servers and the bare metal machines where you can get access, and all of these things are connected to what we call a data plane switch, and I'll explain later what I mean by data plane, so that you can have networking access and you can actually influence the forwarding decisions that are made by this switch, either if you run an experiment within your rack, or if you're going to span your experiments across multiple racks. We also have WiMAX base stations, so this is for the experimenters that want to do like wireless experiments. And then, in order to connect these racks together, so we have racks in a university and another rack, and we need to connect them. We also have networking resources both in the regionals, for example, at Scenic, Nox, SOX. We have networking resources there, and in national research backbones, for example, at Internet 2. So experimenters can actually get resources from Internet 2 and embed them in their experiments to run their, to embed them in their topology to run their experiments. So this is a basic overview of like what is GENI and what does it provide for experimenters and what were the basic two design decisions that were made. One is, slice isolation so that multiple people can use the same testbed at the same time, and the other is deprogrammability so that you can innovate in any place in the network that you want to experiment with. But what is the GENI concept? So what was motivating about building the GENI testbed? Like how was it envisioned to be used by the experimenters? So this is going to be like more of a cartoon story, but just to give you an idea where this is all coming from. So the idea is that you have a student, a graduate student, they have like a great idea. People are doubting, says, oh, this will never work. I don't think this is a good idea. So the first thing now you can do is go and try it out. So you get your idea. You do first in a lab. You do like a small prototype, and then when you're ready, you get a small slice within GENI, and you go and try out your idea to see how, does it work, does it not work, where my design has flaws. And then, you learn, you debug, you adjust your idea, and, it turns out into this thing actually working, so you can start growing your slice and making it bigger and bigger and more to an actual network. And, you're slowly started getting the interest of the people. You publish your papers, you go to conference, you advertise your idea, people started getting interesting in this, and then you can even decide to provide this as a service to real users. So the idea is that, this slicing I was talking about, you can even imagine it in end devices where, you have your phone, and then you can, as you connect to the normal internet, you can also connect to GENI and get services from there. So for all the real users, this will just look like an app, like a web page, like a web application, a web service, and you can access the normal internet and the new services that the student developed at the same time. And in the end, the graduate student graduates. You have like a cool new service that you can imagine, transferring back to the internet, and then you have all these people that are supportive of this idea. So in GENI, we don't fund like research, but if you have like a cool new idea that can use GENI, NSF, write a proposal to NSF, they will give grants for people, that have like interesting new ideas about doing networking research, and then you can just run your own slice in GENI and see what you can do with GENI. So, I just told you the story just to give you an idea of what type of experiments and what type of use we're expecting out of GENI. So GENI is meant to enable, first of all, at-scale experiments. So the whole idea is to give the capability to experimenters to do something they cannot do in their own lab, an experiment that they cannot run in the lab of their university. It's supposed to enable internet-incompatible experiments because, the internet is out there. If you want to run an internet-compatible experiment, you can always do it in the internet. It should give you all the nice features of science experiments. So it should both allow you to do repeatable experiments when you're still trying to test your idea, and so for other people can repeat it if they want to compare it against their own ideas, and also do experiments in the wild, in the sense, like you tried it, if you want to deploy it in the internet first, in a more safe environment, you actually want to see how it interacts with other traffic when it's not isolated. The idea is that people should be able to build services running on GENI and attract actual real users. And because it's such a complex system and distributed, we also want to provide the right tools and for people to actually, measure the slices, get measurements, get their results out of their GENI experiments. So this is all a very, nice and interesting, but how would we go about building such a thing? How would we go about building a nationwide test bed? So, for example, these are all the places that we have resources now, and you see, like the small triangles are WiMAX, the rounds are like compute resources, the links are networking resources that we have, and and this is keep getting updated. So the best place to get information is in the GENI wiki. I'm going to show you later exactly how to get to the GENI wiki that has always up-to-date information about the latest sites, the latest racks that are coming up. So, but how did we go about building GENI? So GENI, it's basically a federation. So there is not one one entity that owns the whole of GENI. The idea is that different organizations decide that they want to be part of GENI, and they are donating their resources in GENI. And there is like the glue that connects all these things is basically a common way that all these things speak to each other. And so you can imagine that the GENI slice can have resources in a university campus. It can have resources on a backbone. It can have resources on a regional. It can have resources on existing test beds. And basically, we're trying to enable existing infrastructure to be federated with GENI, and that also helps us to avoid any type of technology lock-in, right? Whatever, we are basically just designing the way these things are going to be integrated and interoperate, and we're not actually trying to decide on exactly which technology should be used, which technology people should use to provide VMs, which technology people should use to provide raw PCs, how are they going to split their switches into multiple experimenters. And so that is how GENI is supposed to be able to grow and scale into a very large test bed. So you can imagine that it's very hard if you start from scratch to build something that is as big as the internet in order to support these large-scale experiments. So the approach that GENI took was, okay, let's try and GENI enable existing equipment. The same thing I talked before, that everyone has resources in their campuses, in their networks. So let's try and GENI enable those resources so then they can be offered and integrated and interoperate in the greater GENI test bed. So you start by GENI enabling campuses, since the students are the first experimenters, they're early adopters. And then that way, by adding multiple pieces to GENI, you start building a GENI at scale. So let me talk a little bit about the GENI architecture. I also talked in the previous slide, but like you can imagine, here you have the campus, and it has like a lot of resources. It has like the same hardware equipment that is, that is being used in campuses. It's just now that is GENI enabled. And by GENI enabled, you're going to see it later when I'm going to do the demo, that basically is just a common API that all these devices have to speak in order to offer resources to someone that wants to run an experiment in GENI, so that they can actually, when they're building the slice, they can go in these physical resources and actually get a piece of the physical resource. And you have GENI-enabled equipment. In campuses, we have GENI racks. Thank you. So we also have GENI racks, and then they are connected from the campus. You connect to the regional network, where you also have, equipment, and you can actually also have GENI racks, so that you also get some compute power within the GENI network. And this is all connected to the research backbone, and then you can imagine this also going to homes, to like cell phones and stuff. And you notice that in all the resources in GENI, there are basically two connections. One is this connection that is going over here, which is what we call the data plane, and this is where the traffic of the experiments is going to be transferred on. And then we also have this link that is basically the normal internet, where it connects again all your resources, and this is what we call the control interface. And this is how an experimenter will be able to have remote access to different actual resources in GENI, so that they're able to program them, to configure them, to get statistics out of them, results, to monitor them, orchestrate their experiments. So in any resource in GENI basically always has at least two interfaces. One is the control over the control plane in order to be able to configure your resources, and the other is the data plane where you're sending your traffic. And when we're saying that GENI supports layer 2, basically this link here is what is layer 2, right? This is normal internet, normal IP layer 3, and this is exactly where it's the layer 2 connectivity that you can get in your resources. So let me give you some examples, and since we're here also, Georgia Tech is a very, very good example of a GENI-enabled campus. So this is their network topology and how they connect through SOCs, and they're going through the internet to backbone. And they've also did the trials in GENI-enabled commercial equipments. So there are GENI-enabled racks, there are GENI-enabled switches, there are GENI-enabled handsets and WiMAX base stations. And they did a lot of testing trying to integrate this in their campus network. Now, another good example of a regional is the Scenic regional in California, where they actually deployed many OpenFlow switches, which they GENI enabled, and they integrated within the GENI testbed so that people can get networking resources from Scenic and actually affect how their traffic flows within GENI. And you see here that, for example, they have they try to support also multipath experiment by creating, different options in how an experiment can route the traffic within the GENI network. And a very big partner in GENI and in helping us to actually provide this networking, this layer 2 networking, has been Internet 2. They recently switched, so before they had the ION way of providing layer 2 connectivity between campuses. Now they switched to AL2S, and the whole AL2S is built with GENI-enabled equipment. They haven't opened access yet to the GENI experimenters, but the idea is that they will eventually migrate from a prototype GENI to their AL2S production system, so that the experimenter can actually get access and get resources from the AL2S network. They're envisioned to be able to support 100 to 200 GENI campuses, so interconnect all the campuses together. And right now, in the ION, it's in the old way that they were providing. It actually does support dynamic provisioning between different campuses. So you can actually define your topology, and then Internet 2 will go and dynamically configure the necessary links to make that happen. And there is a tutorial later today that will actually go through this process of exactly how we're using this to build custom topologies. I've also talked that we have wireless resources. So basically, in multiple sites around the US, and I'm going to talk about the number of sites later, that we have WiMAX base stations and WiMAX handsets and WiMAX compute nodes. And there were recently an agreement with Sprint, basically with Clearwire, that was later acquired by Sprint, that basically gives access to frequencies for the different GENI sites. And there are all the agreements about what will happen if we interfere with, production frequencies, what will be the emergency shutdown and evacuate of that. There is also a project called SciYNet, which basically enables GENI to run its own MVNO, and they're also partnered with Sprint and Norterra in order to provide roaming. So you can imagine you have a handset, you are in a GENI network, you're using the GENI network, you move away, you get roaming through Sprint for your GENI experiment. And this started recently, and it's an effort led by G. Martin at Clemson University and by Ivan Seskar at Rutgers. Later today, there is a session that's called A Vision for GENI Wireless Infrastructure, where they're going to talk about what is the future of wireless experiments in GENI. I know that there's going to be a lot of people from the industry talking about what is the best standards that we're going to use, how are all these things going to work together, how can experimenters run their wireless experiments. So as you can imagine, in such a large testbed, it's a challenge to run operations. It's a federation, so GENI does not really own any of the resources that are out there. It doesn't really administer them. So any resources that Georgia Tech, for example, provides to GENI, they are administered by the local administrators at Georgia Tech. But this is still a very large-scale testbed that has interactions between them. You're building a slice that it's only contained within one administrative domain, but spans GENI. So we actually do need to have a meta operation center where they're actually monitoring the operations in GENI. This is the GMOC, which is basically run by Indiana University. And they are providing the monitoring of GENI resources. They are the central place that keeps track of outages in GENI. So for example, if Clemson resources are going to go out for an upgrade or something, they're going to notify GMOC, and GMOC is responsible to notify all the right places. They maintain a calendar where it's open to the public and anyone can register so that they can monitor, especially if they're actively using GENI and they want to be sure when they schedule their experiments that all the resources they want to use are going to be up. They monitor most of the GENI aggregates. So when I say monitor, it's the usage, how many slices, what is up, what is down, how many resources a slice has. And they are also the people responsible to do the emergency shutdown in case something goes wrong. So if you have an experiment that for whatever reason goes out of control and it's threatening to bring down the test bed, again, because it's a federated and distributed test bed, it's very hard for one individual administrative domain to, first of all, realize that this is happening and actually bring down the slice. Even if they realize, and GMOC are the actual person that are responsible, that one they see that an experiment is misbehaving, they're the one that can administratively remove it and shut down the whole slice in all the aggregates that are currently being used by that experiment. So where are we currently in building GENI? So we are enabling 5 to 6 regional networks. We are trying to inject more OpenFlow switches in Internet 2. I talked before about the AL2S transition of Internet 2, and they have a schedule and a timeline about how they're going to open this up to GENI experimenters, and there's going to be a talk, I believe, tomorrow in the plenary by Eric Boyd from Internet 2. And we are adding GENI racks in more places. I think currently we are around to 20 GENI racks, and by the end, the plan is to reach to around 50 GENI racks across the US. Now, I keep talking about GENI racks, and what exactly are GENI racks? GENI racks, it's just like computing racks. Like you can imagine, it has compute resources and switching fabric, and they're built one team. The ExoGENI team is a GENI rack that is built out of IBM. So that's, again, when I was talking before about GENI enabling existing equipment, it's basically a production. IBM is building a rack where they're putting GENI software in order for GENI experimenters to have access to it. And then the other effort is out of HP, where HP is building one of the other type of GENI racks. They have some similarities, they have some differences. If you take any of the tutorials that are offered throughout the conference, you are going to get to use one or both of these racks and actually, understand what are the similarities and what are the differences. Now, in GENI WiMAX, there are 26 different WiMAX base stations in 13 different sites. We currently acquired 90 Adroin handsets that were divided among the different sites. And they're also working very hard in providing a uniform experimenter experience when you're trying to run wireless experiments, especially if you're trying to remotely run wireless experiments, which is even harder using Orbit and the yellow nodes that you saw before. And all the WiMAX base stations can be sliced so that they can be shared among different experimenters, and they're all interconnected using Internet 2. So you can imagine you can have an experiment that has some wireless resources at Rutgers, some wireless resource on Internet 2, and then use a wired link between them through Internet 2. Okay? Okay, so next I'm going to move to the actual use of GENI. So if you have any questions about how we build GENI, what is the architecture on that, I think that now it's a good time to ask any questions you might have. I'm sorry? Not really, but what do you mean, so that I can talk more to it now? Yes. I'm not planning to, but later when I'm going to talk about the AIM API, I can go a little bit more into that. So I'm guessing what you're talking about control framework, you're talking about basically different code bases of providing, yes. So in GENI, there were multiple different code bases that were written in order to provide access to GENI. So one was the Orca control framework, where the ExoGENI racks are running, and they're providing resources to GENI. And then there's also the Proto-GENI control framework, the Planet Lab control framework, which are all different ways of actually slicing existing resources. And all of them, as I'm going to talk later, they all comply to the GENI AIM API, so that independent of the way you decide to slice your resources underneath, to the experimenter, it looks like the same API, the same experience. So you can imagine, for example, Proto-GENI is using a customized way to split their compute resources and give VMs to people. ExoGENI, on the other hand, are using OpenStack, but that is transparent to the end user in GENI because they're all compliant to the same GENI AIM API. And when I'm going to go through the demo, I'm going to talk a little bit more about that. Does that answer a little bit your question? Okay, yeah. Mm-hmm. So we have different ways. So that we have what you just said, which is what we call the cert VLANs, where there's basically some VLANs that are statically provided, and anyone can attach to them and attach their resources and use that. But the basic GENI premise is that every experimenter will get their own private VLAN, and this is what the dynamic circuit provision from Internet 2 gives us. So basically, the connections are not there until an experimenter asks for a specific topology, and then we dynamically provision the path and assign a VLAN to the experiment, right? So it's kind of both. It's not. Any other questions? Okay, I'm going to move on, and then later on, if you have any more questions, we can come back to it. Okay, so how's GENI being used today? There are basically two major thrusts in GENI usage. One is for research, like future in Internet architecture, software-defined networking, large-scale evaluation of protocol, cloud research. And the other one is for education. So, and actually we have seen a lot of growth. I'm going to talk a little bit later about this, about actual people using GENI in their classroom in order to give to their students a hands-on experience of networking concept or distributed system concept. It has been used to WiMAX classes. And actually, I know you're going to miss it, but like next door, they're actually having a session right now where they're talking about the experiences of professors using GENI. And in moving forward in the next year and a half, we have actually two major projects that are going to build modules for GENI research, for GENI education that people can actually use in their classroom, take assignments, ready assignments that they have the lab portion running in GENI, and they can just use it in their class. So from the research front, we have, I don't know how many of you have heard for the Future Internet Architecture team. So a few years back, NSF funded 4 major teams, and I think I know a couple more, that are basically doing future internet architecture research. And at least 3 of them have been using GENI in order to develop their prototype and test it. One of them is the NDN team, which is the Name Data Networking. It's about content networking. They did a demo back at the GEC19 about their architecture running within a GENI slice. The other one is the Expressive Internet Architecture that is out of CMU, where the basic idea there is that they want to have an internet architecture that doesn't lock down to any specific protocol, like name it internet, IIP, content networking, whatever. They just want to have a protocol where it's expressive enough that depending on the requirements of the future, they can go and implement it on top of this new XIA architecture. And another architecture is Mobility First out of Rutgers, which they had a demo GEC12, they had a demo in the last GEC, and I know that they're also here today at the demo night that follows tonight, and they also have a demo there, so you can go and visit them. And their basic idea is that everyone now is mobile, they have cell phones, they have laptops, they keep moving around. So if we are to redesign internet from scratch, we have to take this into account. We have to take the fact that the nodes are mobile. And GENI Testbed is the only testbed out there that can support this large-scale evaluation of such new internet architectures, because it provides them with a layer 2 topology that they can go and do testing, and it actually integrates wireless and wired resources if you want to test in large scale these types of ideas. Another interesting research is out of Prasad Kaliam at the Missouri University, which is called the Virtual Desktop Cloud. So Prasad is taking advantage of the software-defined capabilities in the core of the GENI network. So his idea is that many people start deploying their services in the cloud, and how does this affect the quality of the experience of the end user, whether you're using your laptop, whether you're using a desktop, whether you're using your cell phone. And basically, they are trying to monitor the quality of experience at the clients, at the edges, and adjust the routing in the core of the network in order to make sure that they satisfy that everyone gets a very good experience using cloud resources. And they've done like multiple demos, and I know that they also have a demo today later at the demo session, talking about how you can take advantage of software-defined networks and actually making dynamic and real-time decision in the core of the network based on information you get from the applications. Okay. Another very interesting experiment that was run in GENI was the weather notcasting, where basically what they are trying to do is that they have a lot of streaming data from multiple weather predicting sources, whether radars, balloon, whatever, name it. And what they're trying to do is actually do short-scale, very accurate weather forecast. So what will be the weather in the next 15 minutes in this town? And this becomes very valuable when you're talking about, like disastrous type of phenomena, like storms and things that, that you actually want to give to people advance warning that this is coming, evacuate, go to a shelter. So they actually need high bandwidth and and real-time compute resources, and they ran a very interesting hybrid experiment where they used GENI and they brought in the game also resources from Amazon EC2 in order to store and enhance their computer capabilities. And I know that tomorrow at the plenary, if you're here, they're also going to do a demo there running Nowcast again within GENI, and how they can take advantage of the software-defined capabilities in GENI in order to make nowcasting faster and more accurate. I don't know how many of you have heard of GEC19, which is also it's an initiative about building application on this future type of networks. They are partnered with us, so basically we are providing the infrastructure for the developers of this next generation applications. And again, tonight, if you go to the demo night, there are multiple demos that are from Ignite. For example, I think one of them is the elder care. I don't remember out of my head the other ones, but they're very interesting applications that people started building on top of GENI and GENI-like infrastructures. Like, if we had this and it was widely deployed, what can we do to provide better service to the end users? Now, I said that people have been using GENI in their classroom, and we have seen a constant increase of people using GENI in their classroom every semester. People have used it in networking classes, whether undergrad or graduate classes. People have used it in distributed system classes, in cloud computing classes. They have used the wireless resources and teach their students basic wireless concept of signal strength, and they have them go around the campus and take measurements so that they understand exactly how wireless works. We also, in GENI, we also have different events during the years. We go to different tutorials and do different conferences to tutorial. The next major one, we're going to have tutorials at SICOM in Chicago this summer. We do camps, so we just had a winter camp this January, and the next one, GENI Summer Camp, is in June 2014. So if you're a student or if you have students that are interested in getting educated in GENI, this is a very good way. It's usually a week-long camp where people come, take tutorials, and then they also get to work on their own projects in GENI. So they actually, come and live with an actual project, and they get a lot of experience. And there are many people in GENI that, there are many experts there that can help them and answer questions. There are, of course, the GENI engineering conferences like here. Now we're in Atlanta. The next one is in UC Davis. I'm going to talk about it later also. And we also, every semester, since we've seen such an increase in classroom use in GENI, we are offering these train the TA sessions in the beginning of every semester for the teaching assistants that are going to help in the classrooms that are using GENI in order to train them and better prepare them for the class that is coming up in the semester. And the train the TA are usually online, web-based, so that anyone can attend. And the next one is probably going to be early fall for the fall semester of 2014. So this is what's happening now and how people are using GENI now. What is next? So, we're still growing in campuses. We have plans to deploy in 50 campuses. There is a waiting list of more people that want to deploy GENI. And I was talking before about GENI enabling campuses, backbones. What does that exactly mean? What do we mean by GENI enable? This basically usually means OpenFlow or any software-defined technique that enables you to share the networking resources in your campus with some compute resources, usually GENI racks, that's the easy way, and in some cases, WiMAX, GENI-enabled WiMAX base stations. And that is how different campuses are being enabled across the US. So what are the efforts going forward in GENI? So in the next year and a half, we have many people trying to build more sophisticated tools. So as GENI grows in scale, you can imagine that it gets harder and harder to bring up and manage the slices. So we need better tooling in order to support experimenters, to make it easier to run, monitor, archive their experiments, provide the repeatability I was talking about. We are trying to expand the classroom use of GENI. We realize that GENI is very powerful in that sense because it's distributed. It gives access to even universities that they don't have their own lab resources. It's very easy for the professor because they don't have to go and configure their local lab. It's just always there configured. They can just go and run their assignments. So as I said before, there are actually three different efforts. One coming out of UMass Amherst, and they are trying to embed in GENI many of the assignments from the Jim Kuros book. There is an effort out of the UNC University trying to build more modules. And there is an effort out of NYU where they're trying to use GENI for massive courses using MOOC. There are also what we call the shakedown experiments, which basically these are experiments that are pushing the capabilities of GENI. So for example, one of them is out of Renzi, where they are trying to use GENI for other type of domain science, like biology, weather, genomics, and they're trying to see, can these sciences take advantage of the GENI infrastructure? Is it feasible to use GENI to run their experiments? So there's 4 or 5 of these efforts, and if you go again tonight to the demo night, you're going to see many of these shakedown experiments, what are the results, what they have done so far. And also tomorrow at the experimenter roundtable session, many of them are going to just come and talk about their experience using GENI, and actually this will be a common session with the GENI developers and provide feedback about what works, what doesn't work, what new tool they would like to see in GENI. There's also start being talk and work on transitioning GENI to community governance. So how is GENI going to be sustained? How is it feasible to maintain GENI, in the future? Right now, many operations are being run by the GENI project office. So what will happen, later? How can this be picked up by the community? We are also, working with our international partners in order to try and federate with other testbeds. So GENI is just the US initiative of building this type of future internet testbeds, but there are similar activities in Europe, in Japan, in Australia, in South America. And how are we going to federate all these testbeds? So you can imagine an experimenter actually getting resources across the globe instead of just across the US. There is an initial plan to try and federate testbeds on 5 continents. I know that, again, tonight there is a demo by Brecht from Europe that is actually going to talk about what is their effort and what is the current status of this federation. OK, and now I'm going to move to the actual hands-on part and actually show you how to use GENI and do a demo. So do you have any questions so far? No? Cool. So now I'm going to just go a little bit and talk about specific GENI concepts about experiment use, and I'm going to talk a little bit about this common API that I was talking before. So first of all, some GENI terms and definitions. So when you are new to GENI, and especially when you're trying to run experiments in GENI, initially there is like a dump of many terms like that you keep hearing, and they don't necessarily make sense. There's a lot of new terminology, so I'm just trying to explain a few of them here and give you an idea of what you'll be hearing in the sessions for the next 3 days. So the first is the slice, which I mentioned before when we had like this big network and we just want to slice it. So slice is basically an abstraction so that you can put any resources you want for your experiment. So it's basically an abstraction for a collection of resources that are capable of running your experiment. By itself, a slice is nothing. Like a slice does not contain anything. A slice is just one big empty bag where then you can go to the different federations that are to the different aggregates that are federated with GENI, and you can get resources from them and put them in this empty bag. that is your slice, that then eventually you can compose a full topology to run your experiment. So an experiment uses resources within a context of a slice. The slice is the basic fundamentally concept that isolates different experiments, and experimenters are responsible for their slices. So while you're using GENI, you have to keep in mind that these are real resources. GENI is not a simulation environment, it's not an emulation environment. It's real resources in a campus. They're real switches, real computers. So in the end of the day, we need to have someone that is responsible about what is happening in every slice. And the experimenters are, and if you go to the tutorial that's coming right after this, they're going to also talk about the hierarchy and how, there is one person that's always responsible for the slices that are being run. And now, how do you get access in GENI, right? You're an experimenter and you want to use GENI for doing your resources, for doing your experiments. So the first thing you have to do is, first of all, you have to create this slice, right? How do you get a slice in GENI? So there is an entity here that's called the clearinghouse, which is basically the main entity that takes care of users, project, and slices. And it's the one place that keeps all the user accounts, if you will, in GENI. So basically, a researcher, and of course, using a tool is not that the researcher, actually does all the communication. It uses a tool. It goes and says, please give me a slice. It registers the slice, and it gets back what we call the slice credentials, which is basically just a proof that, yes, I'm a valid GENI user, and yes, this clearinghouse trusts me in order to give me this slice to be able to go and add resources. Then you take the slice credential, and you start going to the different aggregates, and aggregates is anything that provides resources in GENI. So for example, each one of the racks is its own aggregate. EmuLab is an aggregate. PlanetLab is another aggregate. So it's any aggregate manager is any place where you can get actual resources. So you take the slice credential, and using a common API, this is what I was calling before, when we GENI enable a device, basically we mean that it suddenly speaks the same API from the experimenter point of view to enable to get resources. And you go there, you use your slice credential, and you actually go and request specific resources, and you get them from multiple aggregates. So you will also hear the term sliver, and I know it gets very confusing. You have slice, you have slivers, what are all these things? So basically, slivers are the things that actually have resources in GENI. So a sliver is one or more resources, but that's in one aggregate. So for example, if you're trying to build a topology that has some resources in one rack, then it has a networking in between through Internet 2 and the resources on a second rack, right? A sliver will be your resources that you have in one rack, let's say 2 VMs. This is a sliver. The VLANs that you're going to get against Internet 2, that's another sliver. And like the VMs you're going to get in the second rack, that's also its own sliver. So a slice is comprised from different slivers, and every sliver basically has actual resources. Unlike the slice that I was saying before is just this empty bag that has nothing, the slivers are what they actually have things inside. The slivers are the things that are actually contain real GENI resources. And again, because GENI is a federation, basically you can imagine wherever the slice intersect with one of our federation, this creates one or more sliver within this aggregate. Okay, you're also going to hear about RSpecs. And RSpecs, you can imagine, is like the machine language in GENI. It's just they're resource specification documents. And they're nothing more than an XML document that describes the resources in GENI. So for example, these RSpecs here, which I know that the font is small and you cannot read, but that's not important. Basically, this is how you would describe one node in GENI. Let's say that you want to ask a VM. This is how you're going to ask for it. And all the tools and the AMs and all the pieces in GENI basically speak to each other using this type of RSpecs. And I'm going to explain exactly how this is happening. So the experimenter tools, again, they're using RSpecs, and they talk this common API, and they're exchanging RSpecs. And we have 3 different types of these resource specification documents. One is the advertisement RSpec, which basically describes what does an aggregate have. So let's see this a little bit. So the first thing you do when you come to GENI, the first thing you want to do when you talk to an aggregate is please describe to me what resources you have. What do you have? What resources do you have to offer? So the first thing you do is ask, and then the aggregate manager will come back with what we call an advertisement RSpec, which is basically a giant XML document that describes all the resources available in this specific aggregate manager. It will say, I have this AEM, I have these VMs, I have these raw PCs, I can create these links, I have an OpenFlow switch. Okay? So you get this advertisement RSpec from the aggregate manager, and now you want to get a subset of this in order to describe your own topology, right? What do you want from this aggregate? And this is what we call the request RSpec. That basically is an XML document that describes exactly what you want out of this aggregate manager. That basically this is what it will have and says, I want 2 VMs and I want a link connecting them, and that is the bandwidth I want on my link, right? So this is the request RSpec that the experimenter will send to the aggregate manager describing what they want. And the aggregate manager will come back with what we call a manifest RSpec, which basically describes exactly what resources an experimenter have within the context of a slice always in this aggregate manager, which is, so you might be wondering what's the difference between request and manifest. The request is usually very generic. You say, I want 2 VMs and a link, but you don't know anything about these VMs. When the manifest comes back, it will say, and these are the IP addresses that you can access the resources, and this is the actual physical PC you are running on. This is the VLAN tag you got from us if you want a link. So the manifest RSpec actually has all the details from the aggregate manager where they then instantiated your topology, right? It will have all the detailed information about exactly where your experiment will be run. Oops, sorry. Okay. So now I'll try and do the demo that I said before, and I'm going to do a very simple demo just to give you an idea. I'm going to get 2 VMs. I'm going to create a slice, and then I'm going to go into a rack and request, like 2 VMs and one link, and I'm going to use a tool called FLAC, which is basically a graphical tool that lets us draw topologies within GENI. So let me go back here. Okay. Hopefully this will do. Okay. So this is the main entrance for most of our GENI users. This is the GENI Portal. So all of you were asked when you register for GEC19 in order to get a GENI account, and you probably have seen this screen before when you went to request an account. So here I'll go and log in to, here I will log in, and that will actually verify that I actually am registered with what I said before, the clearinghouse. So this is where this authentication happens. So, okay. So I put here my username and password, and then I log in. And this is the home page from the for the GENI Portal, and you see here that this is all the projects I'm a member of, and basically here are all the slices that I have, right? So these are all the experiments that I'm running now in GENI. And I'll go under the GEC19 project, and I'm going to create a new slice so that I can run this experiment. So I'm going to say, OK. And I'm just going to say create slice. The slice names are unique within the context of one project. So one project cannot have 2 test slices because this is how we track resources. But you can reuse the same slice name across different projects. And keep in mind that the slice name is unique within a project at any specific point in time. So if the slice, if my slice, this one expires and goes away, someone else can come and recreate this, and now it will belong to a different experimenter. So this is my slice, and as I said, I'm going to use FLAC. So I'm just here going to launch FLAC. Okay. Okay, so you see here that FLAC, and unfortunately I cannot make the fonts bigger, so I'm just going to talk about actual big things you can see. Up here is my username. So the first thing FLAC did is went and said, is this person an actual registered GENI user? And you see here all the things with the spinning wheels. These are all the aggregate managers that FLAC knows about, and I can actually handle and get their, and right now what they're done, and that's why they're spinning wheels, it goes out there and gets what I called before the advertisement RSpec. So FLAC goes to each one of these aggregates and says, please tell me what type of resources you have, so that then it can give to the experiment here a list of the available resources per different aggregate, right? And you see some of them have PCs, some of them have PCs and VMs, some of them are just networks, like the Internet 2 that doesn't have a PC or a VM next to it. And then let me try, I'll get resources from NicerNet, for example. So I'm going to get 2 VMs, and I'm just going to connect them with a link, and then I can just click submit, right? Let me submit this because this will take a while. So this is the point that takes a little bit of a while, because what's happening now is that Flag sends this request RSpec, which is went and created for me, but now the aggregates have to do actual work. They have to go and provision a VM for me, load the operating system, whatever default operating system, since I didn't specify one, bring up the image, configure my network interfaces, install any packages or any software, and then come back and say, okay, now your resources are ready for you to use. So this is actual work, right? It's on the back end, there are real switches that need to be configured and real computers that need to boot up and load it with an OS. So while this is working, let me very quickly. Okay, and again, I know that the font is very small, but I just want to, I'll just point it here that like this is how one node is described in my RSpec, in my request RSpec. Okay, this is my other node here of my 2 VMs, and then, sorry. And right here is the specification of a link that basically, when I specified my node and I sent, and I want you to have a data interface, and then I take this data interface and I say, please connect these two with a link, and these are the properties of the link. I want so much delay, I want so much bandwidth on my link. And this basically is the request RSpec that was sent to the Nicer aggregate. So you see now that the background of Flag turned green, turned yellow. That basically means that the aggregate actually agreed to give me the resources, and they're actually now being provisioned. Once everything is provisioned, it's going to turn green when everything is ready. And you see, again, the spinnings will here, because what Flag does, it goes periodically and asks NicerNet, are the resources ready? Are the resources ready? So it's up to the tool to poke the aggregate for whether for whether the resources are ready. The aggregates do not have like a callback function that you can register to call you when your resources are ready. So basically, you have to go and actively poke once in a while the EMs to see if they're ready. So you see here that when the AM decided and agreed to give me these resources, it also gave me back this manifest RSpec, right, that says, and you got resources on PC2 and on PC2 in my rack, and in order to log in, you're going to use this specific port. And if I go to the link, it would also give me which VLAN tag it's planning to use. So right now, the aggregate knows exactly what resources I'm going to be given, and it's just going out and provision these resources. So now you saw that one of my VMs turned green, and that means that it's ready. So now I just have to wait for my other VM to also turn green so that I can actually have access. And now both of them are green, and you see that the background turned green. So now I can just go and SSH to my machines, right? So okay, and I see here, like this is my VM. I can see the interfaces. Sorry. I can see the interfaces. As I mentioned before when we were talking about the GENI architecture, every resource in GENI has at least 2 interfaces. One is the control interfaces, which is how I logged in and I SSH right now to my computer, and the other is the data plane interface, where it actually connects my 2 resources. Okay. So, and because I didn't ask for a specific IP to be assigned on my data interfaces, the AM made up, 2 IPs on the same network. So if I just try and do ping to my other host, I can verify the connectivity. And this is the place, once you get your resources, this is when you go and install your software, right? This is where you go, you install any software you might have, you configure your nodes in order to bring them up and run your experiment. So after I'm done with my experiment, then I go and release the resources. You should always delete your resources because these are VMs and are both within a rack. So, that's a very cheap resource. We have many of these in GENI. But you can imagine if you start using VLANs across internet too, or if you start using resources on OpenFlow switches, or if these were row hosts, then this is a scarce resource. And there are many people that want to use them out there. So it's always, it's always good practice to delete them and release them for other people to be used. So I'm going to delete it. Now, do we have time? We have a little bit of time. I wanted to also do a second demo because you can imagine, I did this. Yes, it was easy to bring it up, but my nodes are completely unconfigured. And if I have 2 nodes, it might be easy. I go, I install my software, I bring them up, and I run my experiment. But if I start expanding my slice to have more and more, this becomes kind of unmanageable, right? To go on every specific VM and actually configure them separately. So there is a way with this request RSpec, when you define it, to actually also specify what software you want there to be installed, what services you want to be run when the node boots up. And I'm just going to do another demo to you that actually shows how you can do that. So I'll do it in another slice. Okay, I'm going to launch Flag again. So a good thing about describing everything with RSpecs is the fact that once you have this RSpec that describes the topology you want, you can save it off and just reuse it. You don't have to every time go to Flag and start drawing, because that can get very time consuming. So I have already saved my RSpec, which I'm just going to put in Flag, and then I'm going to go over it with you. So I can go here in Flag. Okay, we see that Flag actually goes again and do all the, pokes all the aggregates for their advertisement. So I think maybe in the meantime, I'll just open the RSpec. Okay, so the main thing I want you to notice here is basically these 2 tags. So one is this what says install path, which basically specifies what software I want to be installed on my node. There I basically give the aggregate a URL where they can go and download the software. And then I have another tag here that's called the execute tag, which basically says to the aggregate, when my node boots up, what type of commands do I want to run, right? And here I'm just, run this command for me. You can have as many as you want there. You can have like a list of commands that need to be run when your node boots up. Okay, so this is still. Okay. So I can go in Flag and I can import my RSpec. Okay. Let's pick catering this time. Let's pick a different rack. Okay, and you see here that I have these are my 2 nodes again with a link. I have a server and I have a client. Let me submit this request, and when this goes out, I'm going to show you a little bit of the modifications I've done. So basically what will happen in this demo, the only thing that happens is I have a server, I have a client, and I have automated the installation of a web server and an hyperv server on the server, and on the client I have I install wget and I install hyperv, and then I automate the execution of my experiment. So when the client boots up, waits a bit, and then start doing wget and hyperv requests from the server, right? So and then once I know that this is working, I take this RSpec, I save it, and then I can instantiate my experiment anytime I want, get the results, delete my slice, and do this over and over again. And also because the resources in GENI, there are some resources in GENI that are limited, it's always good practice to try and automate your experiment so that you don't have to do active debugging. And it's a very good practice also because it lets you clean up your installation process and actually know what is installed on your node and how to run your experiment versus the bringing up the nodes, do so many things that then you don't really know how your node is configured and run your experiment to get your results. So, okay. So if I go here, I'll see, you see again here my install and my execute. I see here that I changed the name. Before it was VM. I came here, in my RSpec, it specifies that the name of this node should be client, and the same for the server. If I go, you'll see that, I specified a different name. And here I have my install script and my execute script. And now, it turned yellow. That means that, like the specific aggregate agreed to give me the resources, and I'm just waiting for them to boot up. This will probably take a little bit more time because there is actual software that needs to be installed and configured on my nodes. It's not just booting up the operating system. So in the meantime, let me show you some other stuff here in Flack. So here you see that these are all the AMs. And here you see all the resources that are offered by each AM. So here on the top, you see all the ExoGENI racks. Remember before we talked that we have two different type of racks, the ExoGENI and the IsoGENI. And here are all the VMs. And if I pull down, I will see here different type of VMs. And this was probably not. Okay, this might be a little bit better, not really. Anyway, but you will see here that they have different type of VMs, so that you can ask, for example, a small VM that will only have one core. You can ask for an extra large that I think has like 3 or 4 cores in your VM. And ExoGENI is the one rack that has more resources and actually does not over-provision. So does not over-provision memory, does not over-provision the cores, does not over-provision the storage. So when you ask for 4 cores, then you know that you are the only one that is using this. On the other end, InstaGENI is like it's like a more lightweight option for a rack, and they actually want to run as many experiments as possible, and they do some over-provisioning, so you don't get necessarily performance isolation. So now my slice is up. Hopefully everything starts running, and I am running a web server on the server. So I can go here. I see that that my web server was loaded, and then if I go, I can see the statistics from the wget request, and I don't know if the iPerf test has started yet. It hasn't started yet, but eventually when it starts, I will see here the different logs from iPerf. And this is a way that I didn't really have to do anything. I've just saved everything in my RSpec. I load my RSpec. I send it to the AM, and everything else happens automatically. Okay, so let me go back to the presentation. So this is just the step I did. They're also in the slides if you want to download them later and look over them. It has the request RSpec, the manifest RSpec, which is what I got back. So this is just one of the tutorials I did. If you go to the GENI wiki, you will see that there are many, many more tutorials that you can do yourself at home. The only thing you need is just a GENI account that most of you should already have. Do participate in the Handson tutorial at the GEC. So if you don't already have an account, and especially if you are attending tutorials today or tomorrow, you should go to the help desk and ask them to help you get a GENI account in order to be able to run the experiment. And at the end of each day, I'm actually going to talk about it. Okay, I know that it's small, but I just wanted to go some key points in the agenda. So everything that has this giant green dot, that means that it's good for newcomers. So you don't need any prior GENI knowledge in order to attend the session, because in some of the sessions, for example, are developer section that they're going to go in nitty-gritty details about how the AIM API works, and they're going to argue about specific fields, which might not be of interest to someone that is just starting off in GENI. All the Handson tutorials, you see they have like a small laptop, so you will need your own computer in order to take part in the Handson tutorials that are being offered at the GEC. For most of them, there was some pre-work you had to do. If you haven't done it yet, again, please go to the help desk or find me after the end of this session to help you go through the pre-work for your tutorial so you don't lose time during the tutorials. Now, at the end of every day, there is also a session that is called Experimenter Drop-In, which is basically, it's a very informal, just drop-in session when experimenters or anyone that has a question about GENI or needs help to bring up their experiment, have questions, they want to work with the developers, they can just come in. If you want to run like your classroom in GENI, that's a perfect time to come and find us and talk to us about that. So this is every day in the afternoon. And in the last day, it's collocated with the coding sprints that the developers do. So that's also a good chance because all the GENI developers are going to be in the room in case you have any questions for them or you need their help. Now, before I move on, who is attending the Getting Started tutorial that is right after here? OK, so what I'm going to give you is also, OK. So basically, because many of you have registered, we need to split you into 2 rooms. So please go to the room that is assigned here. OK. Oh, everyone is going. Good. Do you need another one? OK. OK. You're welcome. Please try and go to the room that is specified on the paper so that, you know, we don't have one session that is very crowded and the other one that is... You also want one? Sure, go. I'll give you a few. Can you pass them down? Just pass them down. Go. Okay. So basically, in this tutorial that is coming right after this session, you're basically going to do the 2 examples that I did with you. You're basically just going to get a chance to do them yourself. OK. OK. If I missed anyone, you can come and find me in the front later, and I have more that I can give you. OK, also today, at the end of the day, there is the networking event of the conference, where basically is the demo session. All the projects that I've been talking about during the talk, they're going to have their demonstration there. So just, you know, find what interests you, go and talk to them, visit, see what other people are doing. Tomorrow there might be, you know, there might be a few of birds of feather dinners. If there's a subject that interests you, feel free to join them. It's going to be a little later this time. Usually we do them around 6. There is an industry panel happening at this conference, so we'll do it after around 7:30. Oops. Okay. So when is the next GC? The engineering conference are always open to everyone. The next one is in UC Davis in June. It's a little bit earlier than usual. Usually it's in July. So it's only in 3 months for now. And you know, if you have a student that wants to attend, we also give out travel grants to US academics. And that concludes everything. Do you have any questions? Nothing? You can ask me anything you want about the agenda, the conference in general, the talk.
When you install software in a virtual machine, where does it come from?
So if it's already, you know, hosted somewhere, for example, if you can use apt-get, then you just use this in your install script. If it's your own software, then you have to upload it somewhere on a web server and provide the URL, and they will just go and download it for you.
Will be using the internet?
Yes. All the configuration, it happens over the control interface. All the configuration of the nodes, yes. Very good question. Other questions? Cool, you can come and find me anytime during the conference if you have anything, any questions, anything about the agenda, the GENI, anything in general. Please, before you go, we're going to hand out some feedback forms. And please fill them out. You have to give them back to Regina. And I know it's going to be a little bit, we're asking too much, but for every tutorial you attend, you're going to get one of these feedback forms. Please fill them out. It really helps us improve the tutorials. Like we've done many modifications based on the feedback we get from you. There are only like 3-4 like questions that you have to answer, and then you know you don't feel that you have to answer to all the open-ended questions. So it's very quick. It should take you like 5 minutes to complete, not 5, like a minute. That's not half, Regina. Nice try. Can you pass them down? Pass them down. Oops, I might have over. One, two. Okay. And then I'm going to go to the end and collect the ones. Any leftovers? Oh, you didn't get one? There you go. Any leftovers? No?